Hello class and welcome to our review for section 7.3 and 7.2. Let me get rid of that. Alright, so we'll first start with some definitions and then after that we'll do some examples. So definitions and properties. So the term relative frequency will be the first one here. So let's say we have an event E. Remember we defined event in the previous video in 7.1 review. So we have an event E which occurs m times out of the total n times that the experiment was performed. Then we say that the relative frequency of E is m over n. Right, so now what is a simple event? A simple event is just an event consisting of exactly one outcome. And hopefully the term, it makes sense, simple, only one, right, only one outcome. And we'll see an example soon. So the next bullet point there is for uniform sample spaces. We said these are very specific types of sample spaces. So a sample space in which the outcomes are all equally likely, and that's that E that I wanted. So that's supposed to say equally likely are uniform sample spaces. So taking a look at the example here below, if a fair die is rolled and we want to look at the number that falls uppermost, right, and record it, well, what are all the possibilities? Well, that's our sample space there. We get a 1 or 2, 3, 4, 5, 6, right? So a sample space, remember, is a set, right, containing all of these outcomes. All right, so then we'll say, well, the simple events for this sample space here are the subsets of S which only contain one element, right? All right, so that will be, right, the set containing just the element 1, and the set containing just the element 2, and so on all the way through the set containing only 6. And all of these events, all of these subsets, right, so the probability is 1 over 6. So we can see here that the probability is 1 over 6 and the probability for each outcome is the same. So we have a uniform sample space over here, right? Okay, let's go to the next page. So some more definitions over here. So continuing this, so this will be definitions and properties from 7.3. So given an event E, the probability of an event is always greater than or equal to 0. Always, right? So we don't expect to get negative numbers, only greater than or equal to 0. 0 is possible, but as you can see in the second bullet point there, you only get the probability of the empty set is 0, and the probability of the whole sample space is 1. So the probability of any event, an event being a subset of the whole sample space, is always going to be between 0 and 1, including 0 and 1. Right, and then finally, well, I should say really next, the third bullet point, if E and F are two events of an experiment, then, let's get rid of that, the probability of E union F is equal to the probability of E plus the probability of F minus the probability of E intersect F. This is very similar to our chapter 6 where we would say the number of elements in E union F was equal to the number of elements in E plus the number of elements in F minus the number of elements in their intersection, E intersect F. Right, turns out we can apply the same concept for probability, very related to the stuff we did in chapter 6. And then finally, if E and F are mutually exclusive, and we talked about that in the previous section, that means their intersection is empty, so these two events cannot occur at the same time, then we can say that the probability of their union, the probability of E union F, is equal to just the probability of E plus the probability of F. Because when we're subtracting the probability of E intersect F, we're just subtracting 0 in this case. All right, and then finally, the last bullet point there, the probability of the complement of an event is 1 minus the probability of that event, and we'll use this property for sure in one of the examples. All right, so now that we've seen a few of the definitions and properties, it's time we go to, next one, our first example here. So let's erase this. Okay, So we're looking at a survey, and most of these probability questions are about surveys. Maybe not most, but a good number of the stuff we see on Webassign is about taking surveys. Alright, so we have 800 likely voters, and they're asked about how they feel about the use of red light cameras. Okay, so here are the results. 340 people strongly support using these red light cameras. 198 somewhat support it. 82 somewhat oppose. 146 strongly oppose, and 34 just don't know how they feel about them. Right. Okay, so this is the information that's given to us. Now we want to answer these 6 questions here. Now I took this from Webassign and I added, I think, an extra question there. Well, actually I added multiple questions there. But let's go through and answer them just because they'll cover a lot of the kind of stuff you might see on the quiz. So let's do A. Alright, so what is the probability that a person in the survey selected at random strongly supports red light cameras? So remember, the probability is always going to be the number of people who strongly support red light cameras divided by the total number of people surveyed, right? So in this case, the question tells us that 800 people are surveyed, but if the problem didn't tell us that 800 people are surveyed, they just give us this information over here, then you just add up the numbers, right? You'd say that the total number, so total number of people surveyed would be equal to, you'd add up those numbers, you'd say, all right, I'm gonna take 340 plus 198 plus 82 plus 146 plus 34, right? Add these up, and then whatever that comes out to, that will be your total. So this will be the denominator in the fraction for probability. Okay, so let's answer the question. So we're trying to find the probability that a person randomly selected strongly supports. So I'll say probability of, I'll say strong supports, SUPP for support. Right, so we take the number of people who say they strongly support, which is 340 of them, and then we'll divide that by the number of total people surveyed. Right, so that's your probability. But on the quiz on Webassign, it's going to say round your answer to 2 decimal places. And every question that has you do any probability or anything like that is going to ask you to round to 2 decimal places. So let's do that here. So this is 0.425, and then let's round up to 2 decimal places. So you'd enter 0.43. Right, so be really careful as you enter these in Webassign for the quiz. So this right here is a probability that a person strongly supports. Okay, let's do part B. The probability that a person surveyed somewhat supports. Remember, so there are 198 people who say they somewhat support it. So I'll say P of somewhat support. That's gonna be, you take the people who say they somewhat support it, 198 of them, and you divide that by 800, right? And again, we want to round this to 2 decimal places. This problem doesn't say to do that, but the quiz will tell you to do that. So exactly, this turns out to be 0.2475, or approximately 0.25, right? So that's what you want to enter in for the quiz. Right, so there's about a 25% chance that a person says they somewhat support red light cameras. Okay, let's continue. Now, part C. What is the probability that a person somewhat opposes red light cameras? The people who somewhat oppose, there are 82 of them. So probability of somewhat expose, somewhat oppose, not expose, somewhat oppose. I'll do that. So that's the 82 people over 800. Hopefully you can see that that should come out to be around 10%. Well, it's exactly 0.1025 and approximately equal to 0.10. If we're gonna round off to 2 decimal places, this is what you would enter. Okay, so we've answered 3 so far. Let's answer the rest. All right, so let's erase all this. And hopefully you can see it next. We're going to strongly oppose, so we're just covering everything. So I'll just erase everything at once. Okay, there you go. Alright, so part D. Alright, so strongly opposes, there are 146 of those people, so the probability that a person is strong, I'll just put strong OPP, strongly opposes red line cameras, is you will take the 146 people divided by 800. So hopefully these are pretty straightforward, nothing complicated about these. You just take the ratios. So this is what I'm getting for that. And then this is approximately 0.18 is what I would enter if I were approximating to 2 decimal places. Okay, and next. Alright, the probability that a person does not know how she feels. Well, there are 34 people who, again here I said she, right? He or she. Just because we don't know who these 34 people are. So he, she feels about red light cameras. Well, that's gonna be the probability of, I'll say, probably of IDK. So probably of not knowing how one feels is 34 people out of 800. Right, so which comes out to 0.0425. And again, if you are going to approximate this to 2 decimal places, you'd say 0.04. Right, so about 4% of people say they don't know how they feel. Okay, so that takes care of like those pretty straightforward ones from A through E. Let's talk about F, which is a little bit more involved than the others. So the probability that a person at random favors using cameras. So the wording in these types of questions always matters, right? Because what does favor mean? Well, favor means you support one way or another, right? So favor means you either strongly support or you somewhat support, but favoring definitely doesn't mean anything to do with opposing, so that will be the exact opposite. And favoring has also nothing to do with not knowing, because then you just don't know, you haven't made a decision. So if we're trying to figure out the probability, so this is F, that a person favors these red light cameras, then you'd say that that's the probability of strong support plus the probability of somewhat of a support. Right, so the key in answering this question is just knowing what does favor mean, right? It just means people strongly support or somewhat support. And when you add these two together, so you end up with taking your 0.425 plus 0.2475. So these were numbers we got previously. Add them together, you end up with 0.6725. And then round it off to 2 decimal places, that will be 0.67 is what you would enter in Webassign. Right, so on Webassign, there's definitely going to be a question like F that doesn't exactly just tell you directly what you're trying to find. You're kind of supposed to understand what it means based on the word used. In this case, favors, we had to understand that that meant strongly support or somewhat support. So it'll be a question similar-ish to that. But that's really all you need to know as far as, I guess, a 7-2 question may ask you. So now let's look at the next example. So that's going to be 7.3. And here it is. Alright, so I took this from Webassign number 14 because it's very similar to, again, what you'll see on the quiz. Okay, so now we have 500 freshmen pursuing a business degree at a university. Right, so 324 are taking an econ class, 224 are taking a math class, and 147 are taking both. All right, and we want to answer these three questions here. So what is the probability that a person randomly selected is enrolled in econ and or math? And then another one is exactly in one of the courses. And then the last question is in neither of the courses. So this would be a really good example of why you'd want to use a Venn diagram to answer this. You don't have to, but again, for visual representation, let's draw the Venn diagram here. So remember, our universal set here is now the sample space, S. All right, so we have two subsets, one which I'll call E for econ, and then the other one which I'll call M for math. So E, and then M. All right, so here are the two subsets. Okay, so then we're just gonna fill this in the way we did in chapter 6. So remember, you always start with the number of elements which are in both sets, always. So that's 147. Then using some subtraction, all right, so we know that 324 people are enrolled in an econ class. We have 147 which are in both, so we have 324. We have 147 in both. We have 324 total. So you do 324 minus 147, so you will get that there are 177 people here. Okay, so and then we know that there are 224 people in math class. 147 of them are taking both, so you do 224 minus 147, you get 77 out here. Okay, so then you remember, okay, so how many students do we have again? Oh, there are 500 of them. How many have we not accounted for? Well, if you were to do 500 minus 177 minus 147 minus 77, you'll see that you'd have 401 and 99 will be left. Right, so there are 99 freshmen pursuing a business degree who are not taking math and they're not taking econ either. Okay, so now we have our Venn diagram, we can answer the questions. So let's do A. Okay, the probability that a freshman selected at random from this group is enrolled in econ and or math. So you have to remember that whenever you see the words and or, that means union. Right? Okay, so that means we're looking for probability of E union M. Right, so the probability of taking someone who is in econ and or math will be represented by that. So if we use the definitions from before, so this will be the probability of E plus the probability of M, and then let's do the minus at the end, minus the probability of E intersect M. Right, so that's our formula. Okay, so that would be, all right, so the probability that a student is taking econ, so that's going to be, you take the number of people who are in econ, that's 324, out of the total of 500, plus the probability that someone is taking math is 224 out of 500, minus the probability that they're taking both, that's going to be 147 over 500. And when you do all that, you end up with 401 over 500. But hopefully you can see that you could have just got that from the Venn diagram in the first place, because if you knew that E union M is just this area over here that I'm shading, then you just add up those numbers. You would just do, all right, so what's 177 plus 147 plus 77, and then you divide that by 500. Either way, you would get 401 over 500 as that fraction. So that's the probability, and then if Webassign says to enter as a decimal, well, this is equal to 0.802, and then 2 decimal places, you'd enter 0.80. All right, so there's about an 80% probability that a student selected at random is taking one or the other class. Okay, so that answers part A. Okay, let's do part B. So I will erase these over here. So now we want to know, if you selected someone randomly, what is the probability that this person will be enrolled in exactly one of the two? So again, remember exactly from chapter 6, that means either you're in econ and not in math, or you're in math and not in econ. So that's what exactly means. Okay, so let's do B. And then let me get rid of the shading here. Oops. All right, there you go. Okay, so that means we want to find the probability of, so using the notation that we have, you said this is the probability of, all right, so let's talk about the people who are just in econ and not in math. So that would be E intersect M complement. Or now we want to talk about the people who are just in math and not in econ. So that's M intersect E complement. So you want to find the probability of this first set or the other set. Now, if we remember by the rules for probability, then we know that if we have two mutually exclusive events, then we can say that the probability of their union is the probability of the first plus the probability of the second, right? So I'll say that these right here are mutually exclusive. It's this idea that if we're saying that you're taking exactly one of the classes, then by default it says that you're not taking both classes at the same time, right? So those events cannot occur at the same time. Okay, so that means that this would be equal to the probability of E and M complements plus the probability of M and E complements, right? And then if you had to look on your Venn diagram and ask yourself, what is E intersect M complements? That's just a piece over here, right? So that will be E intersect M complement. That's everything in E and not in M. Well, what about everything in M and not in E? Well, that's everything over here. And you can see that these sets are disjoints. So if you ask for a probability, really it just comes down to, well, all you have to do is add those two numbers and then divide by 500. So that's equal to, oh, one in marker. All right, so that's equal to 177 over 500 would be the probability of E intersect M complements plus the probability of M intersect E complements would be 77 over 500. And add the two. When you do that, you end up with, this is, just give it to you as a decimal, this is equal to 0.508, or approximately 2 decimal places, 0.51 is what you would enter, right? So there is about a 51% chance that a person is taking exactly one of the two classes. Okay, and then our very last question. So what is the probability that a freshman selected at random from this group is enrolled in neither econ nor math, right? So let's talk about what that means in terms of like sets, and then we'll talk about the Venn diagram, of course. All right, as soon as I can erase all this. Okay, so part C is saying that we want to find the probability of not in econ and not in math. That's what it means in neither nor. It means not in one and not in the other. If we were to use De Morgan's laws, so this equal sign here, I'm using De Morgan's laws. It's the same thing as saying the probability of, and you can write E complement intersect M complement as E union M, and then the whole thing complements. Okay, but then if you remember the properties of the probability of the complement of a set, we know is 1 minus the probability of the set, by which I mean this is equal to 1 minus the probability of just E union M. And hopefully that makes sense. The probability of that set complements is 1 minus the probability of that set. Okay, so we can write this 1 minus the probability of E union M. And we know what the probability of E union M is because we found that in part A, right? And it was 401 over 500. So we want to do 1 minus 401 over 500, which we know is 99 over 500. Okay, which is as a decimal 0.198 or approximately 0.20. If we're asked to enter with 2 decimal places, that's what you would say, right? So as the Venn diagram, so what I'm gonna do here is, remember, so this right here is E union M. So if you're thinking what is the complement of E union M, it's everything outside of that, right? So it's, oops, everything that I wanted to draw over here. So the complement of E union M is everything out here. That's everything that's not in U and not in M, or in neither, not U or M, E or M, right? So we're finding the complement of E and M, and that's everything in green out here. And then you just have to figure out, okay, so how many freshmen lie out there? There are 99 of them, so you get 99 out of 500. So what I'm saying here is that you really didn't need to go through any of this over here that I've just circled in order to get 99 out of 500, because you could have just used a Venn diagram in the first place. But you can do it in both ways. It doesn't matter. Just wanted to show you both options. Alright, so this covers everything that I need to talk to you about 7.2 and 7.3. And we're done. But before I go, of course, gotta talk about that password. So the password today is all uppercase. All uppercase. So it's PRB for probability. So uppercase P, uppercase R, uppercase B for probability is your password for the quiz this week. Good luck.